Tonight's video will look at air pressure. So we'll continue looking at the atmosphere like we started before break, and we'll keep going to look at how the weight of this air affects us. So just to review, the atmosphere is the layer of gases that surrounds us here on the Earth. It's made up mostly of nitrogen and oxygen, and we learned a couple different ways that the atmosphere is important to us. Today though, we're going to look at something called air pressure. And so air pressure is basically the weight of the atmosphere constantly pressing on your body. Right? We proved last week or in class today, depending on your class period, that air has mass. Right? We saw that with the balloons. So since air has mass, it also has other properties such as density and pressure. And so air pressure is defined as the weight of a column of air pushing down on a given area. Right? The force pushing on an area is known as pressure. Right? And so we'll take our own notes here. So we're going to air pressure is our main idea. All right, make sure we get a definition of air pressure. And that's basically what you need for this slide. So the force pushing down on an area is known as pressure. The weight of the atmosphere is pushing down on a surface, and we call that air pressure. Now, if you think about it, the atmosphere extends from your head hundreds of miles overhead, at least 100, and then it kind of gets really, really thin. So why doesn't the weight of all of that air smush you into a tiny little ball? And it turns out is because the molecules in the air push in all directions. So imagine if I were to take a stack of books and push it on your head, right? Those books will only push in one direction. They'll only push down. But air pressure pushes in all directions. Right? Up, down, left, and right, the molecules in the air are pushing all directions, so that means that the weight of the atmosphere doesn't crush you, it doesn't collapse in the school, right? Because air in the classrooms is pushing out, kind of balancing that out, and so this air is pushing in all directions. Alright, so my little notes over here, you should probably be putting more detail in than what I've put in. So as far as measuring air pressure, we use an instrument called a barometer, right? And there are two types. There's a mercury barometer and an aneroid barometer. You don't need to know the difference. They're both barometers. They both measure the exact same thing. They just do it in a slightly different way. It's not important that we know exactly how those work. But let's talk about things that affect air pressure. All right. So things that affect air pressure. The biggest thing is altitude. So we'll make this some factors that affect air pressure. Right, the biggest one is altitude, which is another term for elevation. Right, as your altitude increases, your air pressure is going to decrease. And if we look at this diagram, we can kind of figure out why. If you're here at sea level, right, look at all of this air. If you look straight up above it, all of that air that's pushing down on you, right, that's like a big stack of books, right, pushing down, having a lot of pressure. If you were up by here, where this little hiker is, who's getting a little altitude sick, right, there's much less air pushing on you, right? And so the weight of that column of air is going to be less, and therefore the air pressure is also going to be less. We'll talk about altitude sickness in a minute, because I bet some of you have experienced this, especially if you are skiers or hikers. All right, so let's look at density. All right, density, remember, is how tightly packed together the molecules are. And so as we go up in the atmosphere, we know that pressure decreases because there's less air above us to push down. It turns out the density also decreases. Since there's less pressure, the molecules in the air spread out more. And we can see this in this diagram. Here's the surface of the Earth. Down here, this brown arc. And you can see the blue dots represent air molecules. Down close to Earth, there are a lot of them. They're very tightly packed together. So if you were to take a deep breath, you would get lots of air molecules in. But if you were to be up higher, say, I don't know, where like a ski resort, oh, funny that, when you would breathe in, you wouldn't get as much air molecules. You wouldn't get as many air molecules. There's actually just more space in between them. And so that's what's going to give you altitude sickness. You're not getting the level of oxygen, or the amount of oxygen molecules, rather, that you're used to. All right, now your body will adjust over a couple days. So if you know you get altitude sick, if you take a couple days to get up to elevation, then you generally will feel a lot better. Whereas if you just fly in and go straight up to 8,000 feet, If you go to, say, Vail at 8,300 feet, you might get really sick. So that's altitude and density. So kind of these things right here, these relationships are super important. And I would highly recommend that you get those straight into your notes. At low altitude, there's more pressure, the air is more dense. At high altitude, there's less pressure, the air is less dense. Now we're going to leave off today with a little bit of a challenge that we'll look at in class tomorrow, and that's looking at temperature and pressure. So I will tell you that if temperature increases, the air molecules start to spread out, so their density goes down. And what I want you to do is write in your notes what you think will happen to the air pressure if, not density increases, if temperature increases. So, what will happen to the air pressure if temperature increases? Think about our last slide, and I want you to write your answer in the notes. So, given that if temperature increases, molecules spread out and density goes down, what happens to the air pressure if temperature increases? And this will be important for some of our labs in class tomorrow. Alright, like always, put 3 questions you have at the bottom, and I will see you guys in class.